Okay, so we're looking at the next part, which is independent and dependent events. Okay, so this applies. So we've got two events are independent if the results of the first does not affect the result of the second. Okay. Excuse me. So we'll look at some examples of what this means. So for instance, if I've got two children being born in a family, the second child doesn't know what happened in the first child's case. Okay, doesn't know what happened, so its outcome is not affected by the first child. So these are independent events. The second child does not know what happened with the first child, so it's independent. Okay, another example would be two coins being tossed. The second coin does not have a brain. It does not know what happened in the first coin. So this is another example of independent. Okay. So if one event does not affect the other, they're independent. And obviously they are dependent. Events are dependent if the result of one has an effect on the result of the other. And most of the time it happens when you've got things being taken out and not replaced. Okay? So when you don't have replacement, this can have an effect. So for instance, if I take 2 cards out of a pack of 52 cards and I don't put the first card back in, if I take 2 cards from a pack of 52, the second card's outcome is affected by what happens with the first if there's no replacement. Okay, so for instance, when I'm taking the first card out, I'm going to be dividing by 52, whatever I'm looking at, and the next card, there's only 51 cards left. So it's going to be a different fraction that you're dividing by, so it has been affected. So you just have to look for this clue with replacement and without replacement, and that gives you a clue. Okay, so let's have a look at an example. Okay, there's 3 red and 2 white balls in a bag. I take 2 balls out, one after the other, with replacement of the first. Draw a tree diagram and find the probability of getting 2 balls of the same colour. So this is similar to the last video where we had tree diagrams with probability. So I've got red, white, red, white, red, white. So I've got red, 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 white, white, red, white, white. Okay, now I'm going to put the probabilities. I've got 3 balls and 2 balls. So I've got a total of 5 balls. So it's 3 over 5 times and 2 over 5, and I'm putting the ball back in the bag, which means that it's going to stay 3/5, 2/5, 3/5, 2/5. So red will be 3 and another 3, which is 9, and then this one will be 3 times 2, which is 6, and this one will be 2 times 3, which is 6, and the last one will be 2 times 2 equals 4, and when you add up all those numbers there, you get 1. So 9, 15, 21, 25. Okay, so that's with replacement. So these are independent events because you're putting the ball back in the bag. Copy and come across. So this time I'm taking the first ball out and I'm not going to put it back. So this time this is a dependent event. Dependent. And so we start with the same thing. So red, white, red, white, red, white, red, 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 white, white, red, white, white. But this time when I put the numbers in, I've got 3 plus 2 equals 5 for the first one. So it's still 3/5 times 2/5. But now you have to look at what happened before because the ball's not going back into the bag. Okay, so if I take a red ball out, there's only 2 red balls left. Okay, so if I take 1 red out of the 3, there's only 2, but there's only 4 balls left in the bag. But I've still got both whites because I didn't take a white. And this time here, I took a white. So I've still got 3 reds, but there's only 4 left, and there's only 1 white because I took one of the whites, so there's only 1 white left. So this time I've got 3/5 times 2/4 equals 6 over 20. I won't worry about cancelling down at the moment. 3/5 fifths times 2 quarters equals 6 over 20. 2 fifths times 3 quarters equals 6 over 20 again. And 2 fifths times 1 quarter equals 2 over 20. And they add up to 1. And then you just cancel down. So that's 3 tenths, 3 tenths, 3 tenths, 1 tenth. I'm just going to go back. I just think I didn't answer that last question. Okay, so I forgot to answer. Find the probability of getting 2 balls of the same colour. So it's 2 reds or 2 whites. So the answer to that question there would be 13 over 25. Okay, sorry about that. So this time I've got 2 reds, 2 whites. So I've got to add that number and I've got to add that number. So the 2 colours the same would be 4 tenths, which is 2 fifths. Okay, so I'll have a worksheet on Moodle for this one. And that'll be the practice coming up. Okay, thanks for that. See ya.